Y9 chemists, this is week 10's work, which is based on rates of reaction. Now, just following on from feedback that I've received, it was really kind for people to leave the feedback through the Flipgrid. So what I'm going to try and do is I'm going to try and make sure that the videos that I do online are a little bit shorter, just a little bit shorter, so that you can retain all of your concentration as you go through the video. And also what I will do is I will incorporate, where I can, some examples of where it is that we can actually see the work being tested. And here's an example. So this is actually question 7. This was from June 2019. It's paper 3, it's core, so it says it's a more straightforward paper, supposedly. Only takes you up to the C grade. And we need to make sure that we get these fundamentals in place. This question actually started with magnesium carbonate and nitric acid reacting to form magnesium nitrate. Notice that you got some really good use of the suffixes there in this question. So you've also got carbon dioxide and water. So this is a typical metal carbonate plus acid reaction. It will form a nitrate salt because you're using nitric acid, and you've got carbon dioxide that comes off as well. So this question started off with an investigation. They're doing rates of reaction and large pieces with an excess of dilute nitric acid. Now the excess here is actually highlighting the fact that you are not going to run out of acid. What's going to happen is that the magnesium carbonate is going to run out. And the fact that you've actually got the insertion of large pieces means that this question is going to ask about surface area. And the last time that you covered surface area with rates of reaction was actually in year 8, this time last year. So we are yet to touch upon that, but the reason why I've been intrigued by this particular question that came up is because there's a graph. And what you're going to be doing this week is you're going to be honing your analysis and your graphical skills, which I know quite a few of you do find quite difficult to do. So the page in the book that you really need to analyze, and I'm going to give you a very large amount of time for this one. So we were supposed to give you half an hour's worth of work per lesson during Ramadan. I'm actually giving you a very generous amount just to make sure that you actually go through this on the premise that if you do spot anything in this double page spread that you do not understand prior to doing the quiz, that you take a snapshot of it, you send me an email, and you can actually receive some help for it. Because what I want you to do is I want you to do this without any problems or understanding. I don't want you to go into the quiz just thinking, well, I'm just going to try it out and see how it goes, right? Because you're going to get stuck very quickly. It's not going to help you with your exam technique, okay? So first time that we're really digging deep into graphical analysis, you're going to be able to demonstrate the knowledge of a practical method for investigating the rate of reaction. For this particular one, I want you to, and on slide 3, I want you to watch this, okay? It's only a 2-minute clip, and in this experiment, you actually use an elongated test tube, but in the experiment that we've got on our double page spread, we've got a round bottom flash. It doesn't really matter what kind of vessel that's done in, but watch the video. It's also in HD as well. Very good video. Actually, it talks to you about this piece of equipment called a gas syringe, which I'm afraid I don't have at hand to show you. Otherwise, I'd love to demonstrate it to you. Okay, so that's the all part. Demonstrate knowledge of a practical method for investigating the rate of reaction. And the key is gas evolution, because these type of experiments will produce a gas. And so what we want to do is we want to measure the volume of gas over time. We want to make sure that we are measuring volumes over a longer period of time from the start of the experiment to the end of the experiment. We want to see whether the amount of gas that's produced changes from minute to minute, okay? So if it's actually a large volume in 1 minute compared to another minute later on in the experiment, we know that the rate of reaction is slowing down. And how we represent this also is something that we can do with our graphs. We can actually use graphs in order to track this as well, okay? So that's what I'm going to ask you to look through, okay? So I want you to be able to demonstrate understanding of this practical method for investigating the above. Okay, so knowledge is, yeah, I need a gas syringe, I need to use a stopwatch, I need to use something that holds the vessel, I need to plug it together in the right order. Okay, that's knowledge. The understanding behind it comes down to why it is that we actually use a gas syringe. Okay, how do we read a gas syringe? Okay, what does the actual table of results tell us? Because we can actually get a lot from looking at the table even before we actually do a graph. And a good sign of a sign of a good chemist is being able to interpret the tables before you actually do it. Okay, so the equipment that you need and the method that you need to follow is here. Again, it's a very simple chemical reaction that you're doing. You're studying magnesium and hydrochloric acid, okay? And the table that I'm going to be looking at is this one over here, and the graph that I need you to interpret in lesson 2 is over here, okay? Now, there are 150 points that are available for this quiz, so don't go in there thinking it's just going to be a 10-mark quiz. I'm just going to sign it, that's it, okay? I have really thought long and hard about these questions, and I've put lots of traps in there, lots of traps based on what I think misconceptions and preconceptions and mistakes that students make, okay? This is not going to be an easy walk in the park assessment for you, okay? So prepare yourself, make sure that you read the double page spread, okay? Because if you haven't prepared yourself, you are going to show that you haven't prepared yourself very, very quickly, okay? Right, so that's a little warning for you, but I'm certain that you will all be able to prepare well. And then with the extension and the sum, so the sum part, some of you are going to be able to analyze this with the suitable method for investigating the effects of a given variable. So we're talking about given variable on the rate of reaction, including suitable tables and graphs for further analysis. Now this will kind of lead, this is where this lesson will lead on to. Okay, so what I'm doing is, what I'm basically doing is the first lesson that we did last week was I taught you about rates, just understanding what the term rates is so that you're familiar with that. This is the second lesson where I'm now developing your graphical skills. Okay, so when we go into the third lesson, the fourth and the fifth lesson, I'm going to then assume that you can understand tables, you can understand graphs, because what I'll then be able to do is I'll then be able to say, right, okay, let's think about changing the temperature, let's think about changing the surface area, let's think about changing catalyst, let's think about changing etc., whatever variable it is, and we can actually see that in play on this question over here. Okay, so this question is actually about surface area. So the variable that's being changed is surface area. I'll just take you through this. So kind of basic skills that we're building up are, and this is very familiar because you'll actually see and compare that this looks very, very similar to the graph that I've actually shown you over here on this page, okay? So it looks very, very similar, right? So the kind of skills that you need to be able to build up on, I'll just take you through this as well because, might as well. Graph shows how the volume of carbon dioxide changes with types. You've got time over here, this is in seconds. Volume carbon dioxide in centimeters cubed. I'll put a little tricky question somewhere in the quiz just to test whether you're actually on the ball. Are you able to convert minutes to seconds? Okay, a little trap in there for one of the questions. So after how many seconds did the reaction finish? Well, I know from this graph over here that the volume of carbon dioxide did not change after, I would say, around about this point, maybe around about 98 seconds to 100 seconds, okay? So it kind of like touches upon there, and then roughly, I would say, I'd probably go for 100 seconds did the reactions finish. But they probably let you off if you do say 98 as well, because it does look relatively flat there as well, okay? And it is 98 because each one of these blocks is representing 2 seconds. I hope you spotted that, but 10 of these small squares is 20 seconds, okay? A little bit of maths knowledge there. Okay, so that's where you would typically pick off the answer. You'd pick it off somewhere roughly somewhere over here, okay? So the second question over here is from the graph, deduce the volume of carbon dioxide produced during the first 50 seconds. So 50, obviously halfway between 40 and 60. What you'd have to do on the day is you'd have to use a ruler. I think it's that point over there. And then what you'd have to do is you'd have to drag it across. I think it's 34. It's roughly around about 34 centimeters cubed, but you'd have to do that on the day. And I'm in a little bit of a rush. So I'm just going to make sure that you realize that these graphical skills are inherent and very important for success criteria in this lesson. Okay. By the way, the question actually goes on to talking about change. So the change in variable is actually shrinking smaller pieces, larger surface area. So I would suggest that you have a steeper curve right at the very beginning, but because the acid is in excess, all of the magnesium carbonate would react, so you would have a steeper curve, and then it would flatten out, and it would flatten out at exactly the same volume of carbon dioxide as this one did. Okay, so the lines should cross and meet and continue there. Okay, so that's the answer for that. And then how does increase in temperature affect the rate of the reaction? Is increase, so it increase the rate of reaction. That's the simple answer there. Okay, and then how does decrease in concentration? So if you decrease the concentration, it actually take longer, so the line would actually be somewhere probably around here. The questions I actually asked there, it says, how does decrease in concentration of nitric acid affect the rate of reaction? You would just say it would decrease the rate of reaction, okay? And that's how you would get 1, 2, 3, 4, 5, 6 marks. The salt, by the way, is magnesium carbonate, so that's 7 marks. Nice question, 7 marks in a paper that I think has 100 marks. I think 190 marks, I think, somewhere along those lines. And it's a big chunk, almost a whole grade, almost a grade, right? Okay, so there you go. Right, so very briefly, you've got the textbook, watch the video, read through that, then in the second lesson, go through the 150-point practical assessment quiz. Okay, the quiz is over here. Just put your name, and it's got excerpts from the book. I'm not going to reveal too much of it. Just it's multiple choice, but it's a very tricky multiple choice. Okay. Right, and then if you've been successful, demonstrate the knowledge of a practical method. You've done that, including involving gas evolution, understanding of the practical method that's being tested in the quiz. You're analysing it, you're devising it. One other thing that I've forgot to mention: there is an optional extra here, an optional extension for my AZE stars. You can tackle these questions in the yellow box. Purple pen, no need to submit it. That's absolutely fine. The answers are at the back of the book. Push yourself, you can answer those, and no need to turn that evidence in. That keeps you on your toes. Okay, so that takes care of devise and evaluate, draw conclusions from a suitable method for investigating the effect of a given variable on the rate of reaction, including suitable tables and graphs for further analysis. Thank you very much for watching. I hope this was nice and succinct. I kept this very, very short, but I also incorporated a little past paper question in there just to make sure that you saw that it was relevant. Please make sure that you watch the video. It looks great, okay? Just scanning through it. It's one of these things that I would actually like to do in my own time, okay? All right, and the great thing about this as well, so it's nice because it's actually got some of the, it's got the actual suffixes. But do also notice that the experiment that we're covering today was very different, or was different to the experiment that came up in the past paper question I just showed you. This was magnesium carbonate, which is metal carbonate, but the principles of measuring the rate of reaction are the same. You are measuring it using a gas syringe to measure gas evolution over time. Take care of yourself, stay safe. It'd be great to have a like. Please put a subscribe to this YouTube channel. We're almost there, almost to 100 subs. And stay safe, stay indoors. I look forward to getting your marks. Get it in by 3 p.m. on Thursday, or be a blown out Bunsen burner. Okay, take care, kids. Bye-bye.